excited to have Naveen. Sorry, forgive me. Is it Krishnaraj?
Krishnaraj, yeah.
Awesome. Senior data scientist, born out of the oil and gas industry. So, excited to have him on. I guess usually we get started, let's just start, I think we've had a lot better luck lately. Let's just jump into like, what are you doing now? And we'll kind of maybe, work backwards or kind of asynchronously, through your career. But, senior data scientist, what does that mean? What are you working on? What industry are you in? And let's start there.
Yeah, I'm currently in ad tech actually. So I work as a data scientist at Sabanto. We are a tractor automation company. So
Okay.
what we do here is we provide autonomy kit to people who already own a tractor. We provide them with the kit so that they can run their tractor autonomously. So that's the company business model. And I've been with the firm for a year now. Actually, today is my first year anniversary. So
Oh, nice.
yeah,
Congratulations.
yeah.
I think it's to draw parallels between oil and gas and then agriculture is like these are necessary industries that, again, like what the product that each one produces are critical to the livelihoods of, basically everyone on earth. And again, like you need energy to generate the agriculture and even some of the fertilizer and stuff, but at the same time, again, just we need a strong global food supply. So it's definitely interesting to see the convergence of the two of those in your career.
Yeah, like you said, like both are fundamental to human needs actually. Without energy is actually a measure of like, how wealthy a society is, right? So I moved from energy industry. Now, agriculture, like everybody needs to put food on the table. So it's also fundamental to human needs. And in terms of parallels, the technology, there is a lot of overlap in. So we use a lot of sensors in oil and gas, and there is a lot of sensors in autonomy where I work on. So there are various different sensors people bring into this autonomy industry. Like for example, there are LiDAR sensor, radar sensors, and not necessarily we use all of those sensors, but these are like oil and gas. I used to do petrophysics, right? So there are logging tools have all sensors, right? So it's the same parallel, and I can see a lot of different comparison between those two industries, like mechanical aspects of it, and also like for me from the data aspects of it, I can see a lot of different cross-disciplinary applications here, and I was able to transition into this quite easily. Yeah.
And so was this your first role outside of the industry, or had you worked outside of the industry before?
So once I graduated with my PhD in petroleum engineering, I did an internship while I was doing my PhD, but then never really worked in the industry. After that, I went to do consulting, so more of a client-facing job. There, I worked on multiple different problems for 1.5 years, close to 2 years. So there, I did like social media analytics. Had worked on few other problems. I have worked on like some kind of like let's say like financial kind of product analytics problems, and then I had also worked on one of the key problems which I worked on was like connecting our donors to actual people who can donate. So that was another problem which I worked on. So quite a few different domains, and a lot of the first company was like learning the fundamentals like data engineering, cloud, and all these things as well. Yeah, I worked there for 1.5 years, and then I moved to Sabanto in AgTech. So I think I'm coming up on like 3 years outside the industry now.
Okay.
Yeah.
Nice. So, so what technologies or what skills like did you bring? Because obviously you went through again a lot of schooling. It looks like, and I think I saw you had a computational science, aspect to your master's, and obviously you did a lot of kind of data science type work in your PhD even. So, like, how did you, what skills and what technologies have you carried over that have been kind of crossover between the two industries?
Yeah. So while I was doing my master's, I initially started working on this tool called nuclear magnetic resonance, like NMR, right? There, my master's thesis was primarily focused on the processing behind NMR. So before even you get your T2 distribution, so that there is a processing that goes behind it, which is basically signal processing aspect of it. So that is a easily transferable skill to data science field. And my PhD thesis, even though it wasn't petroleum engineering, but the research was developing unsupervised learning algorithm. So the one of the cool algorithm which we developed was say all three of us are talking in the same room, and we have multiple different mics in the room. This algorithm can capture all the voices and separate it out. So it's an unsupervised learning technique. So that is what I worked on, but applied to NMR. But that technique can be applied anywhere else. So that is another transferable skill. And pretty much like the all the 6 years I was doing research, I was working with some sort of data and maths, and like I was familiar with all the libraries. Only new things I had to learn was cloud, big data, when I went to other industries. So those are some of the technology which I had to put in effort and pick up on.
I've heard this question a number of times. You've probably heard it too, being in on your side. But for the average petroleum engineer or manager or somebody in that realm that is not day to day with AI or ML, what are some of the things that you see people saying AI and ML can do, and what are the things that, like, what are the realities? Where do you see the biggest discrepancy as far as that goes? And I know that's kind of a loaded question, but I ask it because personally, I feel like it's used in a lot of different ways and ways it shouldn't be, and a lot of people still have no concept of like what all is in. It's not just like, oh, we click a button and then the model's there and it works perfectly and it was super cheap and it worked the first time and all of these things. But can you kind of elaborate on that?
You touched on a really good point. One key question which I would answer before even doing any data science work is, do I need to use data science, right? Means can I solve it with just a simple physics-based solution? Not a simple physics, like can I solve it with some other domain-based solution? Doesn't really need to be data science or modeling all the time. So the first question is, do I really need a data solution or data science solution here? So that I think is also like somewhat like oversold, because feel like everybody throw in the data and like solve the problem. Like it's not that simple. Like sometimes you have to honor the physics or the domain. So that is one key thing. And another key solution, like another thing which I've heard a lot of people really struggle with, is um, bringing the model to production.
Yeah.
Not everything comes to production. Like your people or like, or to say, people don't really plan well in terms of overall data workflow. So they set up like means what if the model fails when you are about to do like deployment, right? Means so you need to test it as a system as a whole first, plan to fail fast, uh, if you're gonna take the model to production. I've seen a lot of like I've done this mistake myself when I started out, like waited till the last minute when you're closing it on production to see how well the model actually behaves in the data which is gonna be applied to. So that is one other key pain point, I would say.
Yeah, I think that's a huge thing to talk about is just that, do you need data science? I mean, can it be more heuristics? Can it be, rule based? Just I think there's a lot of things where, and again, even if you are about to use some data science, like don't jump to the deep learning model. Like, start with your, linear models, start with things that are actually explainable that you can, show a manager and they're like, okay, that makes sense to me. Because otherwise it's just some black box that you're not going to get buy-in, or it's going to be very difficult to get buy-in with.
Yeah, that is a transition that happens, like when you come into the industry and like spend some time, because initially you want to apply all the complicated model as possible. Then as you mature, you want to start with like more simpler model. Like for the analogy which I have is don't if you want to cut a cake, don't use a sword, like just use a knife, right? So just a simple model which is like fits your solution. That often is more explainable and more easy to deploy and more compute and like more compute effective in most of the time. So that is why we go with a simple model.
So you were saying in like your grad school and everything that you were, yeah, I think it was more probably on-prem or even just local type, data science work. But now you've moved into like, with the consulting, some cloud stuff. So, where you're at now, I mean, because again, I think obviously when it's an autonomous tractor, it's got to be something's running on the edge, right? But I mean, how do you guys ride that? Or are you pushing stuff into the cloud and pushing it down to the edge, like in the tractors, or how does that kind of deployment work, and how are those models trained?
Yeah. So like going back to grad school days, the scale wasn't there. Like it was all like was never a big data problem. It was all simple data, mostly clean data as well. So real data is always messy. So that difference is there. In Sabanto, like yeah, a lot of the models has to be deployed on the edge, and we have an edge camera, and we want the model to be able to work there. So like you said, Bobby, so the whole workflow is to build and train solution on the cloud. Some of the tool stack we use is SageMaker, right?
Okay.
Like we're building like a whole end-to-end pipeline to like take the label data, clean it, like put it in a not clean it, like put it in appropriate format, pre-process it, and then train the data and then process into a format which it can work on edge and actually deploy it there. So that is kind of the whole workflow which we're working on. And again, how do you develop it is actually interesting, because if you do all these things and in the end doesn't work on edge, you spend a lot of time and money wasting all the resources. So you start with something which works on the edge and then go back, then go and label some small data, see if it works there. And then it's a very iterative process. Like if you heard about design thinking, right? Like so it's very non-linear process. That's what we do here at Sabanto. And I can just speak to the data science part of it. Like there are other people who are more on the robotic side. They do even more cooler stuff, I would say, on the edge. Yeah, but this is what I'm aware of.
Nice. So let's dive a little deeper on SageMaker, because I think it's come up a little bit on the podcast, but I'd like to dive into that. And like, because I mean, I've used it a little bit, but because are you guys working in notebooks? And then because you're able to work in notebooks, right? But then you can right from there publish, because usually say if you've got a Jupyter notebook locally, you've maybe got to convert it to a Python script if you really want to like run it on some kind of schedule or whatever. So what does that deployment look like from a notebook? I think you can publish to API endpoints, and just kind of, how does that work across the whole spectrum through AWS and down to the edge?
Yeah, I can say in general, like SageMaker has this processing jobs, right? Which is good with like, pre-processing, like it can be any sort of data. So that is actually script file you can run, and you can orchestrate it from a notebook or from pulling the SageMaker into your local and then giving commands to run it. So there are processing jobs, which is primarily for, you can run Spark jobs there. You can run whatever pre-processing jobs there. There is also training jobs. Again, these are like Docker containers actually pre-built by AWS, right? So it's easy, just plug and play and actually be able to run production load. So training jobs is where you actually train the model, and then from that, the model you can bring in a facility to actually automate the model, saying if it meets this much amount of accuracy, it can get it to you can get it to production, or you can also have a manual way to say this model meets the requirements and it can be pushed to production. And this whole thing can be orchestrated by SageMaker pipelines, right? And then there are versioning. I think SageMaker projects does that. And if you are not happy with SageMaker, there are other tools to do MLOps stuff as well. And then SageMaker endpoints are like, they are very flexible, and you can actually scale it as much as you want, but they're pretty expensive, I would say.
Yeah.
Yeah.
I think that's the one rub on SageMaker. I think it's good, but I've heard it can be expensive. And I think it's one of those push and pulls I think you see a lot now where it's, if you're going to start running these high, even like GPU intensive type things, it starts to make more sense maybe to pull that back down on premise and have your own clusters. And I guess curious on that. I mean, do you guys run exclusively that stuff in the cloud, or do you have like some on-prem resources to run certain jobs, or how does that work?
Yeah, when I develop, I usually like to develop locally. Means to get something scrappy, you don't have to burn money on the cloud, and just do whatever you can. Like, you don't have to train on 1,000 or 10,000 or images. Like, start with like few images, train locally, make the script work, and then go to cloud. That's how we run things. And this is not the only problem we work on. There is another whole module which I worked on is more path planning, the path the tractor has to take. So that mostly I develop locally.
Okay. So it sounds like right now there's a lot of computer vision, like you're feeding images and training the models on those.
Yeah.
Cool. So what libraries are you using for that?
Yeah, just OpenCV for like image processing, and then TensorFlow is what I usually go for deep learning. PyTorch used it a little bit in the past for just courses and stuff. I'm not really fluent in that. I usually rely on TensorFlow.
Yeah.
Nice. That's no, I think there's a lot of really interesting. Yeah.
What's your favorite like for deep learning jobs?
I've only used TensorFlow. I mean, I haven't used a ton, but like when I've messed around with that, I stick to TensorFlow. I mean, I think it's probably 6 of one, half dozen another in a lot of ways. I think I don't use it enough to be like, oh, I need to make this seismic shift. I've got some things that work in TensorFlow, and I can usually kind of build off of them. So.
I think there's a lot of overlap in what you're currently working on and kind of where the operations side of the oil field is going, right? Whether that's frack or drilling, the idea of doing automation in these remote parts of the world on heavy machinery, heavy equipment, and all of that stuff.
Somebody was telling me like oil can drill by itself, like well can drill by itself. So the automation technique there is actually mathematical optimization is what I believe. It's been a while, but that it's the same problem. I couldn't hear a lot of what you said, Bobby. Sorry, John. Is it? Can you repeat it if possible?
No, I was just curious. How do you see? Where do you see kind of the biggest hurdles in trying to do with the push to the edge, right? Like there's a lot of promise with edge, being able to run things locally, being able to automate things, control things.
Yeah, what are some of the difficulties you're having with the push to the edge? Or I think John used to work in that edge space.
Yeah.
So like deploying to the edge, what are some challenges you see there? And again, I think those are things that translate across industries.
Yeah. The only problem is edge is like, resource constrained environment. Like a lot of these models are, resource hungry. So can you slim down the model to be able to deploy on a like really constrained environment? So that is the only problem I've looked at, but there might be other things which other people in the company might be aware of.
Yeah, I think John and I were talking about that earlier about, I think now they're starting to get where some of these AI models are able to be, I think they're small enough. I think what was it, Llama 3, John, you were saying, but they're able to deploy those onto the phones now, like Apple and Samsung are looking at being able to run those locally. It's just, I think it's a natural evolution where if you can run it on the local hardware, it's going to get better. But I think it's just going to be dependent on processing power of Moore's law and just being able to slim down things and say, what do I really need from this? Do I need the full-fledged GPT, or do I need kind of a more targeted model? So,
yeah, that is the same challenge even in computer vision as well. Like, means what architecture do I use to actually be able to run inference on edge? That is one of the most constraints which I have, because if you want to throw like all complex architecture at it, you won't be able to run the inference on the edge at a particular frames per second which you need to actually uh, be the model be useful in real life, right? So that's where the primary constraint is.
Yeah, and I guess something again. I think we get into this often as a theme in our podcast, but even talking about frac operations and whatever else. But like again, in agriculture, like you can't have a tractor just go off the rails and just destroy a whole plot of crops. Like it has to work. It has to stay on a good path. So again, ensuring that that you're not dependent on cloud connectivity, and then that it's able to make decisions in real time. It has to be hypercritical, I would imagine.
Yeah, so we have other, like I said, we have other object detection capabilities, and we have let me size up the things a little bit more clearly. So the automation capability of Sabanto is like, we are given a field, and we are able to do like a plan the coverage of the field, how we want to do it, and there are we also need to plan the paths the tractor needs to take. So there are various modules or methods which we adopt. But let me, in terms of safety measure, there is object detection capability. We have a time of flight sensor which can detect an object and stop. Basically, it won't hit, or it won't hit any obstacles, or it won't run away from the field, because there is a fence which we have, and we won't be operating outside that fence. And in remote locations, we have the connectivity needed to actually be able to interact with the tractor. So, but I would say the remote connection part, I'm not the best person to answer it. There are other experts in the company who take care of it. Yeah.
No, fair enough. And again, maybe like this next question, you may not be like the perfect person to talk to, but maybe you kind of heard. But like, how is it with adoption? Like, with how are farmers and people taking to adopting technology and getting them to buy in?
Yeah, some part of it is actually change management, right? Means not everybody is used to autonomy, and but we convey that like our primary focus is on safety and providing cost-effective and easy to use solution. So we have a solid grounding in one of the industries like turf and sod, and we have people really utilizing our autonomy technology there, and we have farmers being able to adopt for some other operations as well, like tillage and planting. So we have like tested our autonomy capability in various different farming operations. So like I would say, once they see the actual tractor go, it's a totally different ball game. When I was working remotely, I wasn't able to see the tractor in person. But then when I actually see it go and see how easy it's to set up the plan and the path plan and actually launch it, and it's a totally exciting thing, even for me as an employee working there for a few months. Means when I actually saw the tractor. But farmers, when they see it, they get really excited, and we have a lot of adoption of our technology. And I think in terms of acres, we are doing way more acres than what we had done before. So it's pretty exciting time for the company, actually.
That's awesome.
Yeah.
So I think one thing we didn't really get into though is like, so is this like a module or a box that can be tied into a John Deere or a Case International or whatever, or are you manufacturing your own tractors?
Yeah, this is a retrofit kit. So there are various platforms we support, like John Deere, Fendt, and then Kubota. So
Okay.
these are different tractors, and we have a technician who sets it up, and we have a complete closed product, right? It can get attached to a tractor, and we fit the sensors and cameras and everything, and it's good to go. And the farmers can operate by themselves after that.
Great. I mean, and these are big tractors, right? We're talking like the big tractors, or even like it's combines and stuff like that as well, or Because
I'm
I'm
not,
thinking some people may go all the way down to say a lawn tractor. I mean, I don't know, but I'm assuming probably a larger tractor is what you're talking about.
I'm not sure what is it combine or not. Yeah, it's reasonably big size tractor. This was the first time I've seen it, so
Okay.
I would say
A
I would
farming tractor.
I wouldn't be the best person to answer that.
Yeah. No, fair enough. Sorry, my mom's whole side, they were farmers, cotton farmers and corn
Okay.
farmers. So I've got a little bit of background. I could talk enough to get myself in trouble.
What about you mentioned earlier some of the people run into issues with productionizing models and things like that, right? Like I think you're probably well aware about all of those problems that we have in the energy space doing the exact same thing. What are some of the things that people should be aware of, should consider strategies on how to do that? Because we see it all the time, right? Like Bobby and I both have seen it where it's like, hey, I've got this Python script that I wrote that's doing a really good job at X for this well, basin, pad, whatever, small scale. And then they try and go deploy it, in an asset or just in a lease, or they tier things up and it just completely collapses at some point before it gets into full company production. What are some lessons learned and best practices that you've seen on that end? Because that is a very real thing, right? Like we've got a ton of intelligent people that are always working on optimizing things, making things better, making them safer, automating, et cetera. But scaling that out so that the whole company or a whole asset can take advantage of it is still a very hard thing. And I don't think a lot of people really appreciate what that takes until they are looking at it. It's looking them in the face.
Yeah. So there are two pieces on a high level, right? One is why this gets killed at the end is one, you haven't communicated the value to the upper management. So before even doing starting anything, like can you put a dollar amount to this? How it's going to contribute to the bottom line, right? Not every problem will be very obvious, right? So some problem it's ambiguous, but can it affect the bottom line, and can you communicate that to the management, and can you get the buy-in and get the resources to take it to production, right? So that is one thing. Another reason which it gets killed at the end is the change management aspects of it. Like not everybody. There are other stakeholders who are more used to like physics-based modeling or rule-based modeling. They don't really want to use machine learning. So can you get their buy-in, bring all of them in, and like really understand what would success look like, and what would they will be willing to adopt and use. So the success metric is people actually using it and using it successfully and being happy with it, not really a 90% model or 95% trained model. So that is one of the key, I would say. So that those, if you do those things at the beginning more correctly, and then think about like testing the model in a non-linear way. So testing as a system is very important before you even say anything. Like for example, the model can be this much level of like 90% accurate in like when I do it on SageMaker. Will it be that much accurate when I transfer it to Edge? So those are things which gets in the way, and like people, I've made that mistake as well. So think about like the end goal and kind of work your way back. So that is kind of helpful. And again, also like starting simple and then like making it more complicated as needed. So more of a continuous improvement kind of model development. So push something, get it to production, see how it's working, maybe in shadow mode, and then revert it back and build a much better model. So that is how I would build it, and then also like not oversell it. Just communicate honestly what the value is. Not really like say this is going to solve all your problems. Means I usually try to undersell it a little bit. This might solve a little bit of your problem, and then if it gets better, then it's great. So that's how I would do it. Again, different people have different way of doing things, and this is one of my opinion.
Yeah. Do you have to follow up on that, do you have any, because kind of what you described right there is like the CI/CD process, right? Continuous improvement development. What do you have any specific tools or anything like that that you would recommend people use for that? Kind of making sure that that's set up to, for productionization, for scalability, because I've never used them, but I know there are quite a few tools out there that try to help with that in some aspects. But I still think that CI/CD concept is still fairly new or fresh in the energy space, at least, especially with everything being in the cloud now.
Yeah, SageMaker is one such tool to easily help you with that, right? Actually build and even deploy the model and then improve on it, get feedback, and there are tools where like there are tools like experiment tracking in that, see where you are at in terms of like accuracy, and then build on it. So there are already existing tools.
Yeah.
Just use something simple, I would say, and whatever environment you're already in, there are tools like this.
Yeah. Well, because the reason I asked that kind of loaded question, coming from my last role at the Edge company, is that's one area where people don't even know, like it's one thing when you're doing it with cloud deployments or on-prem deployments, you're just your CI/CD pipeline. But then once you get to Edge, it's a whole nother can of worms, right? Because it's like, well, hey, now we're hoping that there's connectivity, or we need a minimum amount of connectivity to be able to deploy this even. That's one of the issues that my prior company ran into. We were doing push button Kubernetes deployments on these Edge servers, and they would work great if you had, 3 to 500 megs of internet connection. But if you got much below that, then, or maybe it was a meg, but whatever it was, there was a very clear threshold. And so then it's like, oh, well, shit, how do we architect the device so that if that happens, it's not going to just brick the device and shut everything down, in the middle of a simple software update, right? I think that's again, this Edge problem. The Edge is coming to the oil field, right? Just like it is in most other places. But I see a lot of people. I foresee a lot of issues that people don't know that they're going to have until they get there, and that's why I ask all these questions.
So one thing I kind of want to hit on the problem you talk about, John, too, and we get Naveen's opinion on it as well, is I think, again, people can do this really cool model and it works like in that localized area. And then, again, I think we talk about problems of maybe how it doesn't generalize, like, maybe it worked really well in a cotton field, but not in a cornfield, or, just certain things that you didn't anticipate. But I think another thing that people really understate, and I think maybe it's better in Naveen's case because they're the company that owns the data model and the schema that the data is produced into, but is like the data engineering aspect of it is like, again, you can have an engineer or a data scientist that does a really cool multivariate analysis, but then do you have the data infrastructure and the data engineering set up to feed that model continuously to be able to run that in production? Because again, it's one thing to do all the pre-processing steps and everything, but then you need a pipeline that's doing those processing steps in real time that can provide that data consistently and kick out outliers and whatever else you need to do. So I think that's huge because I did a really brief consulting thing with an autonomous pipeline company, and they had grown by acquisition, and the data schema for each company they acquired was different. So it was like they built the auto pipe thing for one pipe, but then they're like, this is great. Well, we need to move this over to this pipe. Well, guess what? This was coming from a PI historian. This is coming from some other totally different system. So they had to rewire every time they wanted to go deploy the auto pipe to the different, sides of the business. They had to redo all the data engineering because it was coming from a different source system. They never consolidated and aligned the data systems. So I'm just curious what you've seen on that side, Naveen, from like even the data engineering side and how that plays with the data science side.
I would say, first of all, I'm very thankful to all of them. Like without them, there is no data science. But yeah, on that end, like for example, there are multiple different tables scattered with different information, and they don't talk to each other. That's a big problem. And I've seen data with no entity table, and like I cannot really make sense of what those data are. So there I've seen all those type of problems, and the pipelines are not really robust enough to handle the load as well. That is another problem. And like I feel like it's not just a separate person job. You just throw it at them and like let them do the data engineering work. Every stakeholder has to be involved, like from the beginning to the end, like even the business stakeholders and like has to be involved at the first when you problem solve it, and then set up the pipeline, like kind of what schema you need and stuff like that, because down the line, you never know how badly you messed up, like so you have to go back and redo it and all these things. So it's always good to be like good to have as many hands at the beginning, and like discuss things over, and like uh, maybe argue over a few things so that you get the things right.
Yeah, 100%. Okay, so let's kind of change gears a little bit. Let's kind of go back to the beginning. Like, how'd you get into oil and gas and/or technology? I mean, were you the kid that was ripping apart computers, or when did you see your first computer, or when was that kind of ignition moment for you?
Yeah, oil and gas. My bachelor's was also in chemical engineering, kind of like slash downstream. And like I came here to do masters in petroleum engineering. But then, like after a few months into it, I started working on an experimental lab, and then I met a mathematician who's like a mentor to me, and he kind of helped me transition into technology space, and like I didn't know even like I never knew about Python and stuff and before I met him. So kind of like I think it was like 2015, and that's when I first started really coding for a research purpose, and then that's a gradual change. I wouldn't say like growing up I always wanted to do this, but when I actually started working in the data space, like when I started working with the data in 2015, kind of made all the difference, and I know that this is something which is going to stick around, and because I used to spend like hours, and it didn't feel like I'm putting in the work. So and that's how the transition happened. It wasn't like all planned and stuff like that. It just happened by itself. Yeah.
Was it so? Man, looking at your LinkedIn, you were at U of H. I know John and I had a gentleman there that we were really wanted to get to come work for us, and he ended up going to work for Corva instead. But did you know Fahd Siddiqui?
Fahad Siddiqui.
He was one of the.
Oh yeah, I know him.
He was a fellow, I think, a PhD fellow, I think.
Yeah, I know him. He was a postdoc. Yeah.
Yeah. But he was pretty slick. So I don't know if maybe he was the one or not, but he had done some pretty cool stuff with computers and programming too.
Yeah, oil and gas. I met a lot of smart people, and a lot of people I admire are in the industry. Like for example, NMR, like the tool I used to specialize in. There are many people in the industry I used to admire, and I still volunteer in SP and stuff like that. And like in the mathematical problems which oil and gas people solve is it's not well known right outside the industry. The result, for example, pressure transient testing is not, the mathematics behind this is not pretty straightforward. It's pretty complicated. And
so as far as because I'm always interested when I think like when a solution from another industry can be used across industries. I mean, have you seen that where like you were able to bring like a solution or maybe something from the oil and gas industry to a consulting side that maybe they weren't thinking of it from that viewpoint, or conversely, are there some stuff that you've learned now, say in consulting and at Sabanto, that you're like, man, if I ever went back to oil and gas, I would love to kind of bring this solution or bring this way of thinking over to the oil and gas side?
I would say like I never worked in like oil and gas like full-fledged. Right? I was doing my PhD, and then I was had an internship briefly with Halliburton. So,
Okay.
But I don't think I know enough to see what I can bring back. I've like but oil and gas, the 3 months I spent was also a starting point for me to get into data space, because a lot of other interns were working on data science projects, and I could see the potential of computer vision and things like that. But in terms of going back and bringing skill sets back, I don't know what problems people are working on, and I haven't really caught up with all these things. But I've seen people like whatever conferences I've attended, like I've seen people working on RAG, I've seen people work on like as one of the problems which people keep always talking about is bringing AI into production. So there are some of the things which I feel like can be applied back everywhere, not just oil and gas.
Yeah, I guess bringing up AI, I mean, so I have to imagine in your current role, I mean, obviously you're doing a lot of deep learning, and I feel like, again, people I think rush to the new shiny thing, which again, deep learning was that, a few years back, but it seems like you guys are still leaning into that. But are there applications of something like this, LLMs or AI in the work you all are doing at Sabanto? And, do you see that supplanting or working with deep learning? Like, does one make the other one obsolete, or do they work well together? Just curious where you think there.
Yeah, currently it's deep learning, but it's computer vision, convolutional neural network. So nothing. Haven't done a lot of LLM work here. But in my previous role at Credera, I did a little bit of NLP project. It was more on topic modeling, so just a basic project. But we had like internal groups where we try to learn and specialize on NLP and stuff like that. So I was part of it, and I had also taken courses to do like train myself in NLP, but haven't really got a chance to work on it. And means I was talking to somebody from the technology space as well about this. Like NLP, you need to be a little more curious about the language itself and like understanding of linguistics and stuff like that. I feel like I wasn't really into that. I find computer vision problem more fun and interesting right now. So, but would love to try it sometime. But right now I haven't done much in that. Mostly just learning and self-learning. So
I think that's the interesting thing about the language models, and at least the language models today is, and I didn't realize this until someone explained it to me last week. But like a language model isn't just one thing, right? Like there's a bunch of stuff going on under the hood of that model that understands sentence structure and types, forms of word, like the types of words, what they're being used in, how they're used. It can predict where they're going to be, and all of these things. Like there's so much going on underneath it, and yeah, like people it's all lumped together, right, under a language model. But there's all these things that kind of compounded that have been rolled up into that model that are happening all at the same time that are really kind of incredible, actually, when you kind of break down what it's able to do. But it's I'm curious, walk people through, because we've talked about computer vision kind of high level, and I think people generally understand what computer vision is, but walk people through what it actually takes to build a computer vision model. Because, and it's not just computer vision, right? It's basically any kind of model. But I don't think a lot of people truly understand or appreciate the amount of work and effort that goes into building your own model out of from nothing, essentially.
Yeah, computer vision as a field is like bringing eyes to whatever things you're working with. Basically, you're using a camera sensor, and that's capturing all the visible part of the spectrum, right, into images, and then you actually process those images to run inference on them, right? And there is a certain type of deep learning model called convolutional neural network, which does extremely well on like processing these images. And now they have started using transformers, which are also like used in NLP as well.
Mm-hmm.
So those are the architecture. What it takes to build a computer vision model is sometimes it's not too difficult. It's about like understanding what exactly you need. So there might be already pre-trained model which is exactly suited to your use case. You don't have to train anything.
Right.
You can just use that model and deploy it. But there might be like a lot of cases like it's not that ideal. The environment is totally different. For farming, there is not a lot of data sets for farming, and
Right.
like, there is not a lot of model training for farming. So like basically, it's like teaching a child, right? If the child hasn't seen those, apple or whatever you like shown your child when it's growing up, and it won't really pick it up, right?
Yeah.
So it will take some time to train this model with the appropriate amount of data, and the difficulty, I would say, is understanding what exactly the problem you're trying to solve for. So some might be a classification problem, some might be a semantic segmentation problem, some
Right.
might be a instance segmentation problem. So there are different types of computer vision problems, and there is a post estimation problem. So that is one part of it, framing the initial part of the problem. And another part is like what Bobby said, like bringing in the data, putting the pipeline into
Yeah,
place,
the whole
and
ETL process.
seeing out
Yeah.
actually things scales. But understanding the fundamentals is very important, because when it comes to tuning the model, if you don't know what like the overall architecture is, then you might be stuck. So you might not be able to improve the accuracy of the model beyond a certain point. So
Yeah. Yeah, no, I think it's really cool on one hand in the tech community that there are these kind of, at least on the computer vision side or the data model side, there are like base training sets or base models that you can use to get a head start, so to speak. But you hit something perfectly on the head where it's like they don't know if you don't teach it, it doesn't know, right? Like it is literally just like a child. And so like when people see things from the language models, for example, right, they're like, they think it's sentient, or they think the answer's always right and stuff. It's like it doesn't. All it's doing is retrieving information. It's not coming up with. It doesn't have an intelligence. It has knowledge, right? Like right now, that's the best way I would describe like GPT is it's got a ton of knowledge, but the intelligence, the way it understands that knowledge, is still very young in the kind of life cycle of whatever that becomes. But people confuse just good programming with sentience or like true, it actually understands what it's doing, or it's creating or generating things, and that's not how they work.
It has memorized everything and is spitting it out.
Right,
So
right.
that's how I see
It's
it.
just it might rephrase the way that it's written, which is cool. But that's again, we've just coded language and language structures and all that.
One thing that you brought up that I kind of wanted to pick your brain on too is because again, you guys have a commercial product, and again, people think just open source. I can just take these because you said maybe there's a model like off the shelf that I could use. But I mean, how familiar are you with like something like say the different licensing, and then like being able to define like this is something I can actually use, or I can test with this, but I probably actually can't use this in production because like it's protected.
There are various types of licensing. MIT is usually where it's very liberal, and you can actually use it for commercial purposes, is my understanding. But there are Apache, and like there are a few other licensing, and you cannot you might get into trouble if you, even with libraries, not just models, right? Even with libraries, not a lot of libraries let you use for a commercial application. So I think I ran into that problem a couple of times in my previous job as well. So that is definitely to be aware of. Yeah.
I've got something that made me think of this. How do y'all handle weather with the computer vision stuff? Right, like, because I always, whenever people start talking about models, the first thing I go to is the outlier cases, because that's the hardest part, right? Like, that's what a lot of people don't ever think about, is it's like, I can train, making this relevant to the energy side, right? Like, I can train my model on thousands of frac stages, but if it doesn't know, if I didn't give it a screen out and show it what a screen out was, it will not know what the hell to do when we encounter an actual screen out while we're doing a frac job. Right. And so it's like you have to give it those edge cases, or you hear about like the Teslas running into the back of, a garbage truck because it didn't have a garbage truck programmed into the computer vision model or whatever. But like, tell me kind of, I'm very curious how y'all kind of deal with that, and then making it, kind of higher level. What's one way that people can kind of approach those anomalies and stuff, because those are truly the things that make the big differences in these models at the end of the day.
Yeah, I have two answers for your question. So one is like it's just not weather, right? It's various scenarios,
Right.
like
Lighting.
dark and stuff, right?
Yeah.
So you need to do proper scenario testing and like train for those scenarios, right? So that is very important. Like you could, if you miss a certain scenario, like while you're training, you might actually miss it. But when you do an extensive like testing at a scenario level, for example, it could pick up a person standing straight. Can it pick up a person standing sideways? Back means what are different scenarios you could be facing? Can it just pick up an head? So those are different things you plan for, and definitely like lighting condition and whether these are different things you can train the model for. Another part of your question is not one sensor can do everything. So there are thermal sensors, there are radio, like radar sensors, and there are lidar sensors, and there are different, and there is camera. So there are different types of sensor. Each one is good at different things, and you need to put together all of them to actually build a state-of-the-art model. I'm not saying we're necessarily doing all of this, but that's how a state-of-the-art model is getting built.
Well, so to that question, since you are familiar with automating moving things, I'm a car guy. I'm wearing my donut car hat. There was a debate for a while, I guess, on the automotive side around how they were going to automate driving, right? Like Elon went full in with computer vision, so Teslas have cameras and they've got their own custom GPUs and all this stuff. But then a lot of other people were looking at like LiDAR and sonar and radar and all these other things. I'm curious, where do you, from your real world experience, where do you kind of see that? Is it a combination, like a hybrid of both, you think is the best probable solution that people end up moving forward with? Or
this would be my opinion, not my company's opinion.
100%.
But I would say like my opinion on this is we need more sensors, like all different kinds of sensors. But like our industry is not that complicated, right? Like for especially self-driving cars, it's very complicated. So yeah.
Lots of outlier cases there. Yeah. No, I think
exactly. And it means it's also like life, when because there's not a lot of farming is a relatively safe environment, but like when it comes to like highways and freeways and all these things, there are a lot of things to be looked at.
A lot more variables.
Yeah, exactly.
Well, awesome.
Man,
do you want to jump into a speed round?
Yeah, that flew by. We're already at 55 minutes. That's awesome. So this is speed round. We'll just pepper you with some random questions just to learn a little bit more about you, and then we'll wrap it up. Do you have any good either blogs, social follows, YouTube people that you like to follow on the kind of data technology side you'd recommend?
Yeah, 3 Blue 1 Brown. I think that's what the channel is. Like they show you visual of different, for example, GPT, how you can see it visually. So that is one of the channel. I'm more of a fan of lectures. Like I go to MIT open source lectures and I kind of burn through it. Yeah.
Have you seen any like the Carnegie Mellon like SQL lectures? They have a really good series on there.
I haven't seen it, but I've seen some from CMU. I've seen some computer vision lectures.
Okay, nice.
Mostly for my own work, but yeah, not really SQL. I will check it out. Yeah.
A follow up to that question: what are some ML courses or channels that you would recommend people to follow that are looking into getting in or just increasing their understanding?
The Andrew NG course has gotten way better over the years, and that's something a good place to start. And I think I've said it in other podcasts as well. Like just getting to know somebody,
Yeah.
who's actually working and kind of seeking their guidance. That'll be like a a good way because everybody has different backgrounds and stuff like that, and not everybody has to get into
Right.
like not everybody has to do data science. Like they can do data analysts or they can do data engineering. So it depends on what you like and what you are naturally attracted to.
Yeah.
All right. What's your favorite cloud platform?
AWS,
Yeah.
no question.
And that was a quick answer. What sets it apart for you?
Sorry.
I said that was a quick answer. So, like, what sets it apart for you?
That's something I've used so far. That's something I know very well. And
Yeah.
also like the amount of basically the services there is huge and
Yeah.
it's been there for very long. I like GCP as well. I've used it. Azure I haven't touched it. So
Okay.
Favorite video or board game
board game,
or video game
Or
either
video
one.
game.
video game, Call of Duty with my friends from college. That's
All day long.
classic.
Yep.
yeah, that's some of the fun memories. Yeah.
All right, go last one. Let's go. What's your favorite open source library?
Open source library. I would say it's a pretty hard choice. Pandas, yeah.
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 Have you messed with polars yet?
No, I'm a
Okay.
Spark guy. I
Okay.
use Spark, yeah.
Nice.
Cool.
Well, sweet.
Where Naveen, where can people find you if they want to reach out or ask you any questions?
Yeah, I'm usually active on LinkedIn. I used to be more active. Nowadays, a little less active. I have but yeah, LinkedIn is where I'm active. I don't have a Twitter or anything else.
Cool.
Awesome. Well, thanks for being on. Thanks for reaching out to us. It's great to have you on and kind of see those crossovers between the energy and the agriculture business. So excited to see what comes out of Sabanto and your work.
Thanks, Bobby. Really excited to be part of this podcast. I listen to a lot of your podcasts. I think I listened to even Jessica's one recently as
Awesome.
well.
Oh, nice.
Yeah,
she's very good.
Yeah.
Well, we appreciate it. I'm excited to see what I think, like we've talked about, farming is kind of almost like a bleed into the energy space because we have a lot of the same kind of constraints around remote, lots of big equipment, trying to reduce people, to reduce risk and cost and all these things. So I've never thought about it that way, but I'm going to be looking at the ag tech space to see what's coming down the pipe for the energy side. So really appreciate it, Naveen.